ជំរាបសួរលោកគ្រូសួស្តីមិត្តរួមថ្នាក់ទាំងអស់គ្នាថ្ងៃនេះដែរខ្ញុំបាទនឹងក្រុមដែលមកពីក្រុមទី4ពួកយើងនឹងធ្វើការpresentation អំពីប្រធានបទដែលយើងធ្វើតាក់ទងទៅនឹង CPU ហើយនេះពួកយើងមកស្គាល់សមាជិកនៅក្នុង team 4ទាំងអស់គ្នាមាន
ជាសួរលោកគ្រូខ្ញុំវឌ្ឍនៈមក present ចំណុចដែលខ្ញុំធ្វើនៅក្នុងseries project CPU ហ្នឹងអញ្ចឹងទីដំបូងហ្នឹងគឺ 8-bit register អញ្ចឹងនៅក្នុង 8-bit register ហ្នឹងគោលដៅគឺវាខ្ញុំឲ្យវា store 8 bit ដែលប្រើ D flip flop នៅក្នុងហ្នឹងអញ្ចឹង key component នៅក្នុងហ្នឹងគឺមាន D flip flop មាន input data មាន load control signal clock signal receive signal ហើយនិង output data ដល់ពេលដែលយើង receive signal ហ្នឹង high មួយហ្នឹងទៅកាន់ flip flop អញ្ចឹង output របស់វាគឺ0ហើយមួយទៀតគឺយើង load signal ទៅកាន់ high មួយហើយយើងបើកវាហើយនោះ data វានឹង receive មកវិញមក0វិញហើយដល់យើង apply 8 bit ហ្នឹងគឺចាប់ពី0ដល់7ហើយមួយទៀតហ្នឹងគឺ clock ហ្នឹងគឺវាវាដូររហូត1010រហូតមួយទៀតគឺ data load នៅពេលដែលវា load នៅពេលដែល signal ហ្នឹងវា load ទៅដល់ low ហ្នឹងមានន័យថាវា0ហើយក៏វាផ្ទុក store នៅ current value របស់វាដែរគឺវា hold នៅជាប់នៅក្នុងហ្នឹងចូលមកវិញទៀតគឺ instruction address register អញ្ចឹងយើងអាចកាត់បានថា IAR ដែលវា receive high មួយនៅ high ក៏ flip flop ទាំងអស់គឺវា receive ទៅ0វិញដល់យើងបើកអា high មួយហ្នឹងគឺវាដើម្បី register update ហើយគឺយើងបើកlow 0ហ្នឹងដើម្បីឲ្យវា store ឬក៏ hold value ហ្នឹងដើម្បីកុំឲ្យវាដំណើរការដូរតាណាទៀតអញ្ចឹងincrement របស់វាហ្នឹងគឺយើងប្រើ binary increment ដែលមានដូចជាSLB ហើយនឹងflip flop ដែលវាស្តៀងទៅនឹង binary counter ហ្នឹងអញ្ចឹងនៅក្នុងហ្នឹងគឺអស់ហើយត្រឹមហ្នឹងហើយមួយទៀតគឺ instruction register អញ្ចឹង instruction register ហ្នឹងគឺវាស្តៀងទៅនឹង 8-bit register ដែរដែលវាមាន input អញ្ចឹងចូលមកដល់ instruction register អញ្ចឹងវាស្តៀងទៅនឹង 8-bit register ដែរវាដោយវាផ្ទុក8 bit នៅក្នុងហ្នឹងហើយប៉ុន្តែដែលអីដែលខុសគ្នាហ្នឹងគឺវាអត់មាន output ទេinstruction register គឺវាមានតែ input ទេនៅក្នុងហ្នឹងហើយនៅក្នុង control signal ហ្នឹងគឺមាន load ហើយនឹង clock ដែរក្នុងហ្នឹងហើយវា store នៅពេលដែល user យើងហ្នឹងinput វា load ដល់1អញ្ចឹងclock វាគឺរត់រហូតដល់ពេលដាក់ output វិញដល់ពេលដែល data វា store គឺវា display output របស់ bit ដែលមាននៅក្នុងហ្នឹងហើយក្នុងហ្នឹងគឺយើងអាច change data ដែរតែពេលដែលវារត់មួយហ្នឹងពេលយើងដូរទៅគឺវា update input ឲ្យយើងហើយក៏វាមាន trigger clock ដែរក្នុងហ្នឹងផងដែរអញ្ចឹងចំណុចខ្ញុំគឺចប់ហើយខ្ញុំចូលចំណុចបន្ទាប់
So hello teachers and everyone. My name is Ratana David and today I will present our digital logic project about how a CPU works internally using opcode, decoder and sequencer command circuit built on circuit bus. This simulate how the CPU decode instruction and activate the correct part like RAM, registers and alloy. So the first one is opcode decoder. This is the opcode decoder. It takes a 4-bit input signal label like A, B, C, and D. Each instruction like load A, load B, store A, or add is represented as a unique combination of this bit. And we also use NOT gate to invert bit, checks for 0, and gate to detect the exact pattern. And once match, it activate one of this input, like load A, load B, store A, add. For example, present by inputវាគឺ0000 ចឹងdecoder វា activate load A ហើយ present បើវា0011វានឹង activate ទៅលើ add. So ឥឡូវយើងមកដល់ចំណុចទី2 sequencer command. This is the sequencer command circuit. It takes the activate instruction from the decoder and generate control signal to perform the operations. And it's control read RAM, write A, write B, read A, read B, alloy add. And we also use an enable en input to allow or stop operations. Hey, instruction exam flow. First is load A, reads data from RAM to write to register A, store A, take data from register A, then store it to RAM. Add, read data from register A and B, then alloy add them. After that, store result in A. So to sum up, the opcode decoder checks which instruction is given, and the sequencer command activate the correct CPU part. So ចំណុចរបស់ខ្ញុំអស់ត្រឹមប៉ុណ្្នឹងសិនដល់មិត្តភ័ក្ដិខ្ញុំបន្តទៀត
សួស្តីគ្រូម្ដងទៀតថ្ងៃនេះខ្ញុំនឹងនិយាយតាក់ទងទៅនឹង real sequencer about this real sequencer I implementing the logic gate and flip-flop to create a functioning sequencer that control the traffic light. First, about technical is the project involve several key components. The sequencer circuit design is a clock signal is used to synchronize the transition between state. Each clock pull trigger the flip-flop and update the output state based on the defined sequence. About the reset functionality is the input allow to the circuit to return its initial state, ensuring that the traffic light system can restart its sequence as needed. And about the output, we have four such as S0, S1, S2, and S3 that which represent the different state of the traffic light, with each state corresponding to a specific traffic light color. Let's move to decoder register. About this part, I designed decoder and register set up to manage traffic state. This includes implement logic gate to decode input signal and control the register effectively. This design decoder take two input such as LN1 and LNO and produce four output activating one of the register such as register A, register B, register C, and register E based on the input combination. About four register hold the state for the traffic light like green, yellow, and red. The activate register control the corresponding light. Logic gate. We use AND gate ensure the correct register is activated based on the decode input. Now let's move to my next partner.
Hello, my name is Chinga Kada. I contribute to the project by focus on the following components like as ALU and multiplexer. The first I will talking about at ALU is designed to perform binary addition out to 8-bit input include query handling for accurate calculation. And about technical explanation for at ALU, this component help to binary input and compute. There are some effectively managing query inputs. Is perform addition within the ALU. And then I will talking about ALU. ALU integrate the add ALU and multiplexer into the overall ALU design, ensuring and seamless function for both arithmetic and logical operation. And about technical explanation for ALU, the overall ALU combine the add ALU and multiplexer allow for arranges as arithmetic and logical operation. And one more, the last type for me like multiplexer. Multiplexer focus on employment to select between different data input for the ALU, providing flexibility for various operations based on control signal. And talking about technical explanation for multiplexer, the multiplexer enables the selection as multiple input to fit into the ALU, which is a circuit for execute different operation based on control signal. And then I will move to my friend.
Hello teacher. In my part I will present my project work on the control unit system, which is the one of the key part of the digital computer science. This control unit is responsible for fixing instructions, decoding them, controlling the flow of data between the register, memory, and the ALU. The key component of a control unit circuit has register A, B, instruction, address register, and ROM. Multiplexer, RAM, opcode decoder, and sequencer command decoder register. And the workflows first in the instruction address register fetch the current instruction from ROM. The opcode decoder decode the instruction, identify operation type like load A, store A, add and send control signal. The system select source and determination register while decoder register. Data is transferred between RAM register and ALU. ALU perform addition if the add command is triggered. The results are written back to register as needed. In the circuit, instructions, sequencer, and ROM at the top left, multiplexer, register A and B, at the center, and decoder and control signal generator at the bottom. Example: instruction at A, B, control unit and a board register A and B. ALU perform addition and the result is stored back into a register A.